Hi guys, so today we're going to be doing solving systems of equations in three variables. It's based off of the principles that we did using substitution and elimination. The thing is that with three variables now, it now makes our figure or our picture now three-dimensional. Okay, and so with the systems of three variables, we have several different options in terms of solutions. Okay, one is that there are one solution and these planes intersect at one point. Okay, there is infinitely many solutions, and in that case, the planes intersect in a line. Right? And then the last one is if there is no solutions, and then there could be several different reasonings for why that is. And so these are three of the reasons of why there might be no solution, and that's because in those three planes, they don't share anything in common, right? It's possible that maybe two of them do, right? Or it could be that none of them do, right? And so either way, there isn't one place where all three of them meet, and that would make it no solution. Okay, so with these problems, there are going to be longer because there are three things you're solving for rather than one. So the homework is going to be a little bit less problems, and what we're going to do is we're going to be practicing it for both days, just so that way we do get enough practice without it being too tedious or time consuming. Okay. And so let's get started with example one. We're going to do example 1, 2, 3 before you try some check your understanding ones, just so that way it's not obvious like the first one is one solution, the second one's infinitely many solutions, and the third one is no solution. So we're going to mix it up a little bit there. Okay. Okay. So the first thing what you're going to do is using the elimination method, we're going to first get rid of we're going to get rid of one of our variables. Okay, so it doesn't matter which variable you want to pick first. Okay, but the first one I'm going to do is I'm going to use these two. Okay, and I'm going to get rid of my x's. The reason why I chose that one is just because these ones already have two x's. Okay, so I'm going to do this one, these two. And for the first one, to do it, I'm going to multiply it by -2. Right? Okay, so that will give me -2x, right, minus 4y minus 2z equals -20. Okay, and then the bottom one I'm just going to leave the same, so then it'll be 2x minus y plus 3z equals -5. Okay, the -2x and 2x leave me with no x's now. -4y minus y is -5y. -2z plus 3z is 1z. And -20 minus 5 is -25. Okay, so now I changed it to a two-variable equation. Okay, then I'm going to do the same thing, but with two other ones. So I can't use these both again. Instead, I'm going to do a different combination. So I'm going to try these two. Okay, and then I'm going to choose to multiply the first one by -1. Okay, so that will give me -2x plus y minus 3z equals 5. So all it did is it changed the signs of that first equation, or technically the second equation here. Okay. The third one I'm going to keep the same, so 2x minus 3y minus 5z equals 27. Okay. Add them together, -2x plus 2x, no x's anymore. 1y minus 3y is -2y, and -3z minus 5z is -8z. 5 plus 27 is 32. Okay. And then now, what I'm going to do, okay, is that now it's a system of two equations. So I'm going to use these two now. I'm going to write it underneath here. Wait, I should have used the same color, sorry. Minus 8z equals 32. Now I'm going to solve it using this. Okay. And since these are opposite signs already, least common multiple for 1 and -8 is going to be that 8 here. Okay. So what I'm going to do is multiply this one by 8. 8 times -5y is -40y. 8 times z is 8z, and then 8 times negative 25 should be that. Negative 200. The other one already has the minus 8z, so I'm going to leave it as is. So this gives me negative 42y. My z's disappear. And then my negative 200 plus the 32 gives me negative 168. And then when I divide it by that negative 42, it gives me y equals 4. So now I have one variable, right? So basically, first step is you take two of the equations and choose to eliminate a variable. Then you pick two other equations and choose to eliminate that same variable. And then you use those two equations that result to eliminate it to just one variable. Okay, so now that I have y equals 4, I can either pick to plug it into this one or this one. Okay, it really doesn't matter. So here I'm going to plug it in to this here now. Sorry, I'm kind of jumping a little everywhere, but negative 2, I'm going to now plug in my 4 minus 8z equals 32. So I'm trying to stay as linear as possible here. Okay. Negative 2 times 4 is negative 8, so negative 8 minus 8z equals 32. I'm going to add 8 to both sides. This gives me negative 8z equals 40. I'm going to get rid of the times negative 8 by dividing by negative 8. This gives me z equals negative 5. Okay, so now I have y and z, so I'm going to take the y, and then you're going to plug it into one of these. It doesn't matter which one. Remember, it should be a solution, so it should be true for all three of them. Okay, so I'm going to plug in y to one of them. I'm going to plug in z into that same one. So let's just do the top one here. So I'm going to plug in y here, and I'm going to plug in my z here. Okay. So x plus 2 times 4 plus my negative 5 equals 10. 2 times 4 is 8, plus a negative is really just minus. 8 minus 5 is 3. And then subtract 3 on both sides. I get x equals 7. Okay, and so just like when we solve a system of equations with two variables, it's an ordered pair. In this case, since we have three variables, it'll be an ordered triple. It'll be x, y, and then z. So the x is 7, y is 4, and z is negative 5. And there you go. So 7, 4, negative 5. And what you can do is you can then plug it into each of them, and it should result in a true statement for all three of those equations. Okay, so now we're going to do the same thing. Okay, we're going to pick one of our variables to get rid of. So let's just do x. We're kind of already used to that anyway. So I'm going to start with this. Okay, so with 4 and 6, right, the least common multiple is 3. Okay, so to do this one, it will be multiplied by 3. Multiply this one would be negative 2. Okay, so this will result in 12x minus 18y plus 12z equals 36. So multiplied, distributed the 3 there. Then distributing the negative 2 to the second one, negative 12x, 18y minus 12z equals negative 36. Okay. What ends up happening here, right, is that this cancels, this cancels, this cancels, leaving me with 0. And then 30 minus 36 cancels, leaving me with 0 equals 0. Okay? The equation 0 equals 0 is always true. So what this means is that the first two here are actually the same plane. Okay? So these two here are actually the same plane. Okay? So we just need to see now if it intersects the third plane. Okay? So I'm going to now try, since they're the same, it doesn't matter which one I use. I'm going to do this one and this one. Okay. I'm going to eliminate x again. Okay. And so then 6 and 5, GCF is 30. So I'm going to multiply this one by 5 and this one by negative 6. Okay. So top one or second one will be 30x minus 45y plus 30z equals a big number, 18 times 5, 90. Bottom one here, negative 30, I forgot my x, negative 30x plus 48y. This is minus 60z equals negative 120. Okay. What results is 3y minus 30z equals 90 minus 120 is negative 30. Okay. And then I can also divide by GCF 3, which is y minus 10z equals negative 10. Okay. And what this means then, right? They're not all the same or anything. And so they do intersect in a line. I just don't know which line because I need another equation in order to find that, but I don't have it. And so this, what it means is for my 0 equals 0 same plane, it means that I have infinitely many solutions. Okay. The reason why is because if this resulted in another statement like 0 equals 0 or something like that, then all three of them would be the same plane. If it resulted in a false solution, something that wasn't true, then it would be, if it ended up in a false statement, it would end up being no solution. Okay. But in this case, we ended up with an equation, which means that I have infinitely many solutions. Okay. Which means sort of, two of them are the same plane and then it intersects another one, okay, but they intersect in a line. Okay, so now let's do the third one here. Okay. So again, we're choosing to eliminate one of our variables. Okay. So let's start with the first one here. I'm going to eliminate A. Okay. 6 and 9, the least common multiple is actually 36. Okay, so this one I'm going to multiply by 6, and then to get this one to be negative 36, I'll multiply by negative 4. Okay, so this becomes 36a plus 72b minus 48c equals 24 times 6 is 144. Okay. Bottom one here, negative 36a, 18 times 4. This is going to be negative 72b. Negative 4 times negative 12c is 48c. And this is negative 120. Okay. And what we see here, 36 minus 36a is 0. 72b minus 72b is 0. Negative 48c plus 48c is 0. 144 minus 120 here is 24. This here is a false statement. This will never be true. And so here, that means that they will never intersect, which we don't even have to consider the third one now. That means that there is no solution. There's no point where all three of them have in common because even these two don't have a place that they have in common. What? Okay. So what you're going to do now is you're going to work on check your understanding, not check your progress, but check your understanding number 5 and 6. And then once you're done, come check your answer. Okay, so for CYU 5, you should have gotten no solution. And for number 6, you should have gotten the order triple 408. Okay, if you got those correct, you can move on to example 4. If not, here is your explanation. Okay. So here, what I did is I first started by combining the first two. Okay, in which order you do it, you might have a different process, but in the end, you should still get the same answer. Okay. So here, the first two, I just decided to get rid of the x, so I wanted 2x and negative 2x. The first one could stay the same since it already has the 2. The bottom one, I multiplied it by negative 2. Okay. And that resulted in negative 5y plus 9z equals negative 5. Okay. Then I did the second and the third one, also getting rid of x again. Right? So I wanted 4 and negative 4, so I multiplied the top one by negative 4. That gave me negative 4x minus 8y plus 16z equals negative 12. The third one stayed the same. And then when I combined it, I got negative 5y plus 9z equals negative 20. Okay. So then I was going to solve the system with these two, so I just rewrote the blue one here. And then, since I already saw it has both negative 5y, I just needed to change the bottom one into a different sign. So I did that by multiplying by negative 1. That resulted in 5y minus 9z equals 20. And then when I added the two equations together, I got 0 equals 15. Since this is a false statement, that means that these do not touch, and so there would be no solution. There's no place, no ordered triple where would work for all three of these equations. So that's why it's no solution. Right? With this one here, right? This one did end up working out. So again, I just chose to get rid of x first. You can choose to get rid of y or z first. It really doesn't matter. It's still the same process. It's just in a different order. Okay. So I used the first two. I did x's again, so 6 and negative 6. So multiplied the top one by negative 6. I ended up with negative 8y minus 7z equals negative 56. Okay. Then for the other ones, I chose the second and third. I didn't have to. I could have chosen the first and the third. But yeah, I chose the second and the third. And I, again, since I got rid of x's in this one, I'm getting rid of x's again here. So I did 6 and negative 6 again. Okay, so multiply the bottom one by negative 2. That resulted in negative 10y minus 5z equals negative 40. Okay. Now it just becomes two equations. So to get rid of the next variable, this time I chose to get rid of z's. Okay, I could have done y's, it really doesn't matter. Okay, but I chose to get rid of z's. So with 7 and 5, the least common multiple is 35. So the top one I multiplied by 5. And then the bottom one, to get it to the opposite sign, I multiplied by negative 7. Okay, that resulted in these two equations here. And when I added it, I got 30y equals 0. Okay. 0 doesn't mean that, oh, it's no solution. It means that right now 30y equals 0. Okay, so to get rid of the times 30, I divided by 30, and 0 divided by 30 is 0. So my y value, in which all of these three planes touch, is where the y value is 0. Okay. Then I could choose to either plug it into the purple one here or the blue one. Okay, I chose the blue one. It really didn't matter. So I replaced the y in the blue one with 0, okay, and solved it. I ended up with z equals 8. So now that I know y is 0 and z equals 8, I can plug it into any of these three to solve for what x is, right? Because it should be true for all three of them if it's a solution. So the top one seemed the simplest, so I plugged it into that one. I replaced the y with 0 and the z with 8, and that gave me an x equals 4. So my order triple is x is 4, y is 0, z is 8, so 4, 0, 8. Okay, so the last one here that we're going to do for is example 4. Okay. Oh, this is supposed to say Andrew Chang, not change. I guess autocorrected might have corrected it. But Andrew Chang has $15,000 that he wants to invest in certificates of deposits, also known as CDs. Okay. For tax purposes, he wants his total interest per year to be $800. Okay. He wants to put 1,000 more in a 2-year CD than in a 1-year CD, and he wants to invest the rest in a 3-year CD. Okay, we want to know how much should Mr. Chang invest in each type of CD. Okay, so before we get started, let's start by defining our variables. Okay, so there's 3 different CDs. There's a 1-year, 2-year, and a 3-year. So let's do X is the amount in a 1-year CD. We'll do Y as the amount in a 2-year CD. And we'll do Z as the amount in a 3-year CD. So it starts by defining the variable so we know what it represents when we get our X, Y, and Z. Okay? So we know that he has $1,500 to invest. Okay? And so that means the total amount of each of them should equal to 1,500. So that means X plus Y plus Z should equal 15,000. Okay. I'm going to use my highlighting. So that's where this comes in. Okay. The next part is about the total interest that he wants to spend, or he wants to get. Okay, so he wants his total interest here, so that's from this as well. Okay, so for the first year, he'll get 3.4%. So this as a decimal is 0.034. This one will be 0.05, and this one here will be 0.06. Okay, so I just changed it into a decimal. So from the first year, it'll be 0.034x. Okay, because that's how much interest he'll get from the first one. Okay. The second one will be 0.05 for the y, 5% for that. And the third one will be 0.06 for the z. And the total for all of that interest will be $800. Okay. So this comes from this. Okay. And then the third thing we know is that he wants to put 1,000 more in a 2-year CD in a 1 year and then invest the rest. So what this means, in the 1 year, let's put 2,000. So that means x plus the 1,000 will be what y is. Okay, so with this one, I'm actually going to solve it with substitution. Okay, and I'm going to start, since I know what y is, I'm going to substitute it into each of these. Okay. So I'm going to take this y and substitute it into both of them. Let's do that. So since it's doing here, here. So this one now becomes x plus 1,000 plus z equals 15,000. Okay, which when simplified will be 2x plus 1,000 plus z equals 15,000. And then if I subtract this 1,000 over, wait, I don't know why I wrote it like that. It would be 2x plus z equals 14,000. Okay. Then I'm going to do the same thing for this one. Okay, so 0.034x plus 0.05, and then we know the y is x plus 1,000 plus 0.06, that's a 6, plus 800. So here this becomes 0.034x plus 0.05x plus 50 plus 0.06z equals 800. So this becomes 0.084x. And I'm going to subtract the 50 over. Equals 750. Okay, so now I have the whole x's and z part. Okay, so I'm going to use these two, this one here and this one here, to do my next one. Okay, so I'm going to get rid of the z's. Okay, so since this one is 0.06, I want this to be negative 0.06. Okay. So what this will become is this will become negative 0.12x minus 0.06. Z equals negative 840. Okay, this one can stay the same. So 0.084x, 0.06z, 750. Okay, so then negative 0.12x plus 0.084x will give me negative 0.036x. The z's now go bye-bye. And then negative 840. So it's negative 90. Okay. Then I'm going to divide here. Now we'll get x equals 2,500. Okay, so that's how much is in the first year CD. Okay. So then, now I can figure out what y is, right? Because y is just x plus 1,000. So 2,500 plus the 1,000 will now give me y. So that means y is 3,500. So this was from this. Okay. Then, now I know what x and y is, and I can solve for z. So here, that means 2,500 plus 3,500 plus z should give me 15,000. So this gives me 6,000 plus z equals 15,000. Subtract the 6,000, and I get z equals 9,000. Okay, so what does this mean? In this case, since this is a word problem, you can't just say x equals this, y equals this, z equals this, right? You have to actually answer the question of how much should he invest in each type of CD. So Mr. Chang should invest, okay, starting with x, 2,500 in a 1-year CD, and y, 3,500, and that is in the 2-year CD. And z is the 9,000 in a 3-year CD. And there you go. Okay, you're going to do the last one here, and then check your answer. Okay, you should have gotten 13 free throws, 15 field goals, and 9 3-pointers. If you got it right, you can get started on the homework. If not, here is your explanation. Okay, so first I define the variables. So x is the number of free throws, y is the number of field goals, and z is the number of 3-pointers. Okay, so the first one equation I wrote was on points. Since we know he made 70 points, free throws are 1 point, so that's the 1x here. Field goals are 2 points, so 2y, and 3-pointers are 3 points, so 3z, equal to the 70 points total. Okay. We know that he scored 37 times, so that's why the number of free throws plus field goals plus 3-pointers should equal 37. Okay. And then this one here is from this. The sum of field goals and 3-pointers, so field goals and 3-pointers, y plus z, equals twice the number of free throws, so twice the number of free throws, 2x minus 2. Okay. Then what I did is I decided to use substitution. Maybe doing elimination would have been better so that I didn't have to deal with so many fractions, but I chose substitution. Okay. If you chose elimination, then you just need to move the 2x over, and then that actually might be easier than the way I did it here. So that's using elimination. I did substitution, so I changed it to solve for x. I added the 2 over and then got rid of the 2 by dividing by 2. Then, since I know x equals this, I basically substituted that in for the first equation here and the second equation. Okay. I'm now going to cover this. Okay, and then to get rid of the fraction, I decided to multiply the whole equation by 2. So that gets rid of this, divide by 2, and then this becomes 4y, this becomes 6z, this becomes 140. And if I keep simplifying by combining like terms and getting rid of the plus 2, I get 5y plus 7z equals 138. Okay. Again, then I substituted the same thing for the second equation. Decided to get rid of the fraction of dividing by 2 by multiplying by 2, so that got rid of this part. And then, so that's why the y became 2y here, the z became 2z, and the 37 became 74. Okay, then I combined like terms and moved the plus 2 over. That gave me 3y plus 3z equals 72. And then using this now, I used elimination. I eliminated my y, so 5 and 3, that would be 15 and negative 15. So multiply the top one by 3, the bottom one by negative 5. So 15y, 21z, 414. 15y, 21z, 414. This one with the negative 5, negative 15y, negative 15z, and negative 360 here. Combined, added the two equations, the y's disappear. 21z minus 15z is 6z, and 414 minus 360 is 54. Got rid of the times 6 by dividing by 6. That gave me z equals 9. Now that I know what 9z is, I can plug it into either of these. I chose the bottom one here. Substituted in the 9. 3 times 9 is 27. Moved it over by subtracting it. Gave me 3y equals 45. Got rid of the times 3 by dividing by 3. Y equals 15. Now that I know y and z, I can plug it back in. I thought that the middle one was the simplest one. And so x plus 15 for y, 9 for z equals 37. Combine like terms to be 24. Subtract the 24 here, x equals 13. And so 13 is free throws, y is 15, so field goals, 15 field goals, and z is 9 3-pointers. There you go. That's it for today. Have a great rest of the day. Bye, guys.